This is Mr. Beck Does Your Homework, physics homework number 11, question number 7. It says the magnitude of each force is 205 newtons. So I've got 205 newtons pushing straight horizontally. Now I've got myself a monster, 205 newtons pushing at a 20-degree angle. It says the force on the right is applied at an angle 20 degrees, and the mass of the block is 10 kilograms. The coefficient of friction is 0.134. It says what is the magnitude of the resulting acceleration? So, free body diagram. I have gravity down. I have a push force up and to the right. That's this one. I have another push force straight to the right. I'm going to draw that from here out. So I've got another F push this way. And then I'm going to have a normal force up this way. And since I have a coefficient of friction, I've also got friction this way. That's a lot of forces. So let's see what we can figure out. First thing usually is kill the monster if I can. And I can because I've got an amount and I've got an angle. So that push force, I'm going to split up into a force in the x world and a force in the y world. So that's Fy. So this is F push. I'm going to cross it out here. So this push force is going to break into an x and a y, x over and y up. If I were to redraw this free body diagram now I've got my normal force up. I've also got a y that's up because this one's up to the right. So I've got a y that's up. To the right I've got an F push. And I've also got an Fx. Down I've got gravity. And backwards I've got friction. So this is my free body diagram with components. So now I can apply my equilibrium for up and down because I know that my normal force and my y must equal my gravity. And then left and right I'm going to have a net force. These two are to the right minus the friction to the left will be the net force accelerating the box. So up and down are going to be equal because this box is not going to fly in the air and it's not going to sink into the table. So I know that my normal force plus my y force is going to equal my gravity force. Or I can rearrange this to solve for the normal force. So my normal force is going to be my gravity minus my y. Well, my gravity is going to be mg. So my normal force is going to be, my force of gravity is the mass times the acceleration of gravity minus my y force. What's my y force? How do I get this if I know this angle and the push force? Well, I know that my push force times the sine of theta, because this is opposite, will give me the y component. So that is going to be F push times the sine of theta. So for me, my normal force is going to be mass of 10 kilograms times gravity of 9.8 minus 205 times the sine of 20. That will give me my normal force. All right, so now I know this one, I know this one, I know this one. I know y and normal, and I know gravity. I know my push force here is also 205. My force in the x direction, that's going to be this one. That one is going to be a trig component of this. And then I've got friction pointing the other way. So now I can look at my net force. My net force is going to be the difference between what's pushing to the right minus what's pushing to the left. So to the right, I've got F push. I've got Fx. And I'm adding that. And then I'm going to subtract from that my force of friction. So my net force is going to be F push, which for me is straight 205. My Fx is going to be the other 205 times the cosine of 20. And from that I'm going to subtract my force of friction, which is mu times my normal force. Do I know my normal force? I sure do. I just calculated it here. So when you plug in your 205 and 205 cosine 20 and you subtract the mu times the normal force, that'll give you a net force. And what does the net force do? The net force causes the mass to accelerate. Net force equals ma. It's asking for the acceleration, so I have one last thing to do, and that's to take my net force divided by mass. and that will give me my acceleration. It's going to be my net force divided by my mass. So again, monster, kill the monster. Free body diagram, my up and down are going to equal because the normal is going to respond to however much it's being pushed in. So normal plus y equals gravity. Notice that normal and gravity are not equal because I've got a monster. To the right, I've got a push and an x. To the left, I've got a force of friction. So these two minus this one gives me a net force. The net force causes the mass to accelerate. Divide by mass, there's your acceleration.